The first thing we notice is a lot of companies are not even if you incorporate LLM technologies into your application, you still have application logic as well. You still have CPU-based workloads. So it didn't displace those use cases, which is good for us. But not just that, it added new use cases, right? Like now you have GPUs you are potentially monitoring for inferencing or whatever. And you do need to it did create new use cases to observe for sure. One thing we noticed is you can imagine at let's say monitoring a GPU cluster is not too different from monitoring a CPU cluster at the infrastructure level. Yes, there's different metrics, there's different things you're caring about, but it's still in our tool, it's just as effective to use our tool to monitor a GPU cluster versus a CPU cluster there.
Hello, everyone. You're listening to Startup Project. I'm your host, Natraj. My guest today is Martin. He's the co-founder and CEO of Chronosphere, an observability platform for modern containerized world. He was previously engineering manager at Uber, technical lead at AWS. In this conversation, we'll cover building scalable and reliable observability platforms, the challenges in managing large-scale distributed systems, and future of observability. If this is your first time listening to Startup Project podcast, don't forget to subscribe to us. It helps us reach more audience. Martin, welcome to the show.
Thank you for having me. Looking forward to our conversation today.
So how did Chronosphere start? When did you decide that, I have to stop working at other companies and start my own company?
Yeah, actually, the story goes back to when myself and my co-founder worked at Uber. We actually led the observability team there. So we face a lot of the challenges that we're currently solving for our customers here at Chronosphere inside Uber internally. And what we ended up doing was creating a bunch of new technologies in that solution. We open sourced a lot of those, and it sort of showed us that these problems that we were solving for Uber inside observability were also being seen by the rest of the market as they started to containerize their environments. And that ultimately led us to say, hey, we should probably create a company here so that we could bring the benefits of these pieces of technology to the rest of the market as well.
And what is the type of the problem that you specifically faced for Uber and that was not available outside at that point of time?
Yeah, it's a great question. I would say if you think about observability, it's just the visibility and insights into your infrastructure, your applications, your network, and the business, right? The concept is not new. We've had observability software, it used to maybe called APM software or infrastructure monitoring software. Like the concepts have been around for a long time. There's been a lot of solutions that have been around for a long time. What ends up happening is when you start to containerize and modernize your environments, two things happen from an observability perspective. The first thing is you can imagine you're breaking up your larger monolithic applications into smaller microservices. So there are more tiny pieces running. You're running on containers, which are running on VMs. There's just more things to monitor and observe. And that generally produces a lot more observability data. So the very first problem you'll find is either there's too much data for your backend or it costs you too much. That's one effect that a lot of folks in the industry see when they start containerizing. And the second thing is you can imagine the types of problems you're trying to solve on your monolithic apps running on a VM are slightly different to the types of causes of problems in a distributed, containerized environment there, in the sense that you can imagine a lot of APM software was really looking at, let's say, how the software was interacting with the hardware and the operating system. Whereas in a containerized world, you generally don't get even access to that level. Plus, also more often than not, a cause of your issue is some downstream dependency did a deployment or a feature flag change or something like that. So the causes of the problems have changed over time as well. And hence you really want a tool or a product that's highly optimized for the newer types of problems that may be coming up. So those are probably the two big problems we saw at Uber. It was producing way too much data and it cost us way too much. And it wasn't really the ideal tool for these new environments. And when we looked at the market at the time, there wasn't actually anything we could buy. So we ended up being forced to build our own solutions at Uber.
What were the services at that point of time that were available? Because right now I think there's a lot more competition in the observability space.
It was still, I would say, a lot of competition back in those days, but different types of companies for sure. Back then tools like App Dynamics, New Relic was very popular. Actually, even Datadog was, I think that they were like a Series C company when we were looking at this problem space. There were a lot of different solutions, but none of those solutions were targeting containerized environments. You can imagine, like the majority of the market in 2014 when we were solving this problem at Uber had not containerized. This is like pre-Kubernetes becoming the de facto platform there, right? So most folks were running on VMs, and I would say an APM style piece of software was probably the right solution. Whereas today, that's changed quite a lot. But yeah.
And you mentioned open source. Was this M3 database that you open
Yeah,
source?
it was it was actually multiple solutions. One was M3. That was the back end, and it was a time series database that was great for storing metric-based data, so numerical measurements over time. Jaeger was created from the same team as well. That's for distributed tracing. That's a CNCF project today. And bits and pieces of various clients and things like that were also open source as well. But yeah.
So you saw a gap in the market that no one is addressing. You decided to start the company. What were those initial days like? Like talk to me about like getting your first five customers.
Yeah. So to your point, we saw a gap in the market, and that wasn't even when we were creating the technology. I think it was much later, especially around, I remember 2018, 2019, when, at I think a KubeCon in Seattle, actually, all the major cloud providers said, "Hey, we're going to go all in on Kubernetes," and it was sort of only then that we realized, okay, there's a real gap in the broader market. You can imagine, just like every other startup, nobody knew who we were. You go to somebody and you're like, we're Chronosphere, we're a tech startup. Nobody really knows you, and there's no brand recognition there, right? So it was actually quite difficult in the beginning. And to get the first five, I would say one or two of them were, I would say, companies that we had worked with people at those companies when we were at Uber. So there was a little bit of trust on, okay, this was the observability team at Uber. We had worked with them before. We have used the technology before. So that gave us a little bit of credibility and trust on a couple of those companies we were working with. But honestly, the rest of it was just, you can imagine the typical outbound. I was on LinkedIn every day sending 500 messages to various VPs and CEOs out there saying, "Hey, this is us. This is the problem we're trying to solve. Is there any way I can get you on a call?" So a lot of I would say outbound emails and messages to try to get those opportunities.
In some way, it's also like mission critical, right? Because the observability data is used to find issues, live issues in your product or service, and to fix those issues if anything, because it tells you how your service is running or not running. Um, so it's always hard to convince when you're creating a mission critical technical product and selling that to a company.
Yeah.
So what those initial customers were like, okay, we are just transitioning it to Kubernetes, so this might be a good time to test it out because we have not entirely built out our service.
Yeah. Actually, it was interesting. We see more of that today. Initially, it was a lot of companies that had actually were already transitioned. So there were a lot of tech forward companies that were running mostly containerized environments at scales like 2019, 2020 by the time we started the company. To your point, I think being mission critical actually probably doesn't help us or didn't help us at a startup, right? Because you're trying to convince this company to replace a piece of mission critical software that they are probably purchasing from a big public vendor and a well-known brand name. And here you are as a 1 or 2 year old startup trying to replace that piece of mission critical software. I think what that translated to was the benefit of switching had to be so large that it would outweigh the risk of replacing a mission critical piece of software. And for us, really early on, the majority of the benefit there was both on the scale and the performance side of the back end, but also on the cost efficiency from the beginning. It was just so compelling it was so much more cost efficient than the other solutions they're using today. And a lot of companies cared about that back then, plus a lot of scale and reliability properties. And, we're not talking like it's 20% more cost efficient. We're talking like it's like 4 to 5 times more cost efficient, right? I think that the gap had to be very large back then because, of course, like, if I'm in their shoes, that's a pretty risky decision to make to bet on a startup for such a mission critical piece of software. But yeah.
So, so you sold companies that were already operating at scale. on the cost benefit that they're going to get by
Yeah, on,
adopting.
on on both the cost benefit, you can imagine scale because these were tech forward companies already. They were growing their businesses at, you can imagine, pretty incredible rates, 100% year on year, something like that. So they really had to care about the future scale. They had to care about the reliability of observability. If you think about it, if you want to provide your customer 3.9 SLA, you actually really need your observability tool to give you better than 3.9. Because if your observability tool can only run at 3.9s, like there's no way you're giving that guarantee. So those properties for that profile of company that was tech forward at scale, was a good fit there at the beginning.
Um, in terms of, let's talk a little bit about like the products that you offer. So can you talk a high level, what are the products that Chronosphere today offers? And also talk a little bit about the business model.
Yeah. So there's two products that we offer. One is our observability platform. That is a pretty typical observability platform. You can imagine it can ingest and store logs, metrics, traces, events, all of the various types of data that's produced by your infrastructure, by your applications. We obviously ingest and store that, and then we provide all of the analytics capabilities on top, so it can help you debug issues. I would say compared to, that's pretty standard of these platforms. Compared to the others in the market, it probably differentiates in two main ways at a high level. The first is cost efficiency. And we don't just do that from unit economics there. That is one way, but actually, what we realized is in observability, there is a lot of waste. You store and pay for a lot of data that you may or may not need. And what's interesting is the way these most observability companies are set up is that they charge you for more data that you produce. It's a pretty typical SaaS type of model, right? So you can imagine these existing vendors are not motivated to have you reduce that data volume. They're not actually motivated to tell you what's useful and what's useless. But us, Chronosphere, as a disruptor to the industry, we had to do something different. So actually, what we did was we created features that would actually show the customer what is and isn't useful. And you can imagine they can make some decisions, and we gave them a bunch of tools to optimize the data, thus that we can align that they are only paying for their useful data. And you can imagine the useful data is generally a subset of the whole data set there. So that's our way of ensuring that the costs are lower. It does reduce your cost, but it's really a guarantee that you know that everything you're paying for is useful. It's being used, right? So at least you know your dollars are being well spent. Of course, the overall dollar amount is reduced. And then, as I mentioned earlier, you sort of need a different tool that goes and optimizes for, look, the probability and the probable causes is probably a downstream dependency. It's probably like generally software doesn't break unless you do a change, like you roll out a new version or you change a feature flag. So it's looking for those changes and trying to correlate them with issues and whatnot. And I would say generally what our customers have found is that they probably reduce their time to detect and resolve a problem by around 65% or so. So it's generally more effective at solving problems than their existing tools that they're on. So that's the observability platform. That's how it differentiates in the market. Separately, we have a separate solution called a telemetry pipeline. It's actually called a observability telemetry pipeline. And what that does is actually you can actually install this inside your environment. You don't have to do a migration over to Chronosphere. You can like put it in front of, let's say, Splunk or Elastic or some existing tool, and it's actually going to try to both route and transform the data it collects to those backends, but it can also reduce and optimize those data volumes as well, right? There are certain things you can do in your environment to gain that efficiency there. You can do things like, okay, let me route subsets of the data to, cold storage S3 or Azure Blob Storage and things like that to reduce your cost there as well. So that's a separate product we have. You don't have to use that with our observability platform backend, but you can imagine that they provide a similar benefit without the migration there.
So it's like if it's almost like selling to customers who use your competitors. Um, is Splunk and because they're technically your competitors, right? As a product, they also have observability, and you can still use telemetry pipeline to reduce costs, even though you're not actually switching to
Exactly.
Chronosphere?
So, ideally, we would want everyone to switch, especially for their containerized environments. But, that might take some time. You might be locked into a contract. There may be other difficulties there. So the telemetry pipeline both allows you to do that transition eventually, and not just a Chronosphere. You can imagine with something in the middle, you can perform a migration from one tool to any other tool, but also reduce the cost in the meantime as well. So it provides a lot more short-term value to our customers, and then longer term to maximize that value. Ultimately, ideally, you would switch over your observability backend as well.
Do customers using observability products think about the predictability of cost?
I would say in the last 2 to 3 years, as the economy has changed, they care about it a lot, right? And it's not just the absolute dollar amount. Like a lot of our customers are seeing what fraction of my revenue, what fraction of my operating expense do I spend on both cloud infrastructure overall, but in particular observability, because it actually gets quite expensive there. And the predictability and knowing what relative percentage of cost that is matters, because even though there's an absolute dollar amount for sure, but you can imagine if your business and revenue was to grow 2x, but your observability costs are going to grow 3x, that is just a bad efficiency model over time. And over time, you're going to get far less efficient, right? So the predictability and being able to both see, but also control that is actually key. And it's the controlling piece as well. So you can definitely see it from a dollar amount, but you can imagine when we provide our customers with the tools that show them where their spend is going to, what piece of the data is useful, how it's being used by the end users. It really just gives our customers an ability to pick and choose and make those decisions. You can imagine a executive can say, "Hey, I actually only want to spend, let's say 5% of my operating budget on observability." Well, great, you can do that. We're just going to show you, okay, this is how all of your data is being used. And in order to get your budget back to 5%, here are some tools you can use to reduce the volume of data being stored and being used there.
I think there were a series of products that I used to see a while back, which promised cost cutting in cloud.
Mm,
And I always felt like, products that already have observability sort of data um, can do that in a better job of, reducing cost overall for your
sure,
infrastructure.
sure.
Is that a right assumption? And do you help your customers not generally for like predicting, the observability service costs, but in general your cloud costs or your infra costs? Is that something you help your customers, or is that a product or a feature that is potentially on your roadmap?
Yeah, that's a great question. So the interesting overlap between observability and I'd say cloud cost management is all of the utilization data, like how many cores are you using, at what percentages, how much memory you're using, how much disk you're using. All of that data already exists in your observability platform. It's already there, right? And you're not just using that for cost management. You're using that to know when there's a spike in CPU and whatnot. So what's interesting is we already have that data for other purposes. What we do for our customers, and it's a great point, like maybe we should productize this, but what we do for our customers is we actually just allow them to have open source based dashboards and visibility into that. So you can imagine if we already have the utilization, you can run something like OpenCost, which is just an open source project on top of this and actually see cost insights on your infrastructure. So we give them the benefit because all the data is there. We don't try to double charge for it or anything like that because again, you're using the data for something else. So a lot of our customers are using us for that. Not alone, they have to pair it up with an open source project right now, or perhaps pair it up with a product that they buy off the shelf for that. The advantage of doing that with Chronosphere is you don't have to duplicate that data into the cloud cost management platform and Chronosphere. You only pay for that data once, and you can have two benefits from it. Would not perhaps be a terrible idea for us to try to monetize that in the future, but right now our main focus is on, you can imagine the core benefit of observability is improving that uptime, reducing the number of incidents and whatnot, and we feel like that is generally providing a much more benefit to our customers than perhaps on the cloud cost management side today.
So one of the things that we see with, technology deployments is they are attached to one or two clouds. Like customers have attachment towards one of the big three clouds. Um, And all the three clouds have some version of observability products. I know Azure has Azure Monitor, AWS
Yep.
has, I forgot the name, but Google has its own
Yep.
observability
Like
platform.
CloudWatch and yep. Yep.
Yeah, CloudWatch. So how do you compete with those products? Because there might be some kind of bundling pricing. As with scale, there is pricing advantages for all the three clouds. How does being a product from not these big clouds? I can also see an advantage because there are certain areas in the cloud where not being part of any ecosystem is actually an advantage. I'm curious how you think about playing in this ecosystem,
Yeah.
right? When there's so many, so pretty much every service has a competitor from and a partner
Yeah.
from the big three clouds, right?
Yeah. Yeah.
So I would love to know your thoughts on how do you think about this playing with the ecosystem.
Yeah. I probably look at this from maybe two or three different approaches. The first thing I think that's unique about observability in particular, versus other categories or types of products is you got to remember that observability is a thing that's meant to tell you if your infrastructure is up or down, right? It's the thing that's going to tell you I'm up right now, I'm serving customers. Now, if that's running on the same infrastructure, so let's take, for example, I won't pick on Azure. Let's pick on AWS, right? Like their services depend on, let's say, like their observability services depend on S3 and Kinesis, for example. So when S3 goes down in a region, your infrastructure is probably impacted. Like you as a company probably depend on S3. It's probably impacted. The thing that's meant to tell you you're impacted also depends on S3 and is down at the same time. And this is just generally what happens, right? You can imagine US East 1 goes down, half of the internet goes down, right? But it's actually in that moment in time when you need observability the most. And the fact that it's coupled, it's not the same for databases and things like that, but for observability, the fact that it's coupled is actually there's a huge advantage to decouple that. There's a huge advantage to say, I don't want my infrastructure that I'm monitoring to be also the infrastructure that my observability comes from or runs on. And it's not just from the cloud providers. I actually think companies out there should think, wait, even if I use a SaaS provider, what do they run on? Because if they run on US East 1 of AWS, it's not going to matter because even though it's a SaaS provider, we have a common dependency there. So that's actually pretty unique. And for us, not just as a vendor that's not a cloud provider, but actually our architecture is purposely single tenanted. So we have an ability to make sure that we are not on the same public cloud infrastructure that you, the customer, is running on, so that when you need us the most, I can almost guarantee you that we won't be affected by the same thing, right? So I think that's one thing I think about there, and that's a huge disadvantage about observability services in particular in the cloud providers that maybe don't exist on some of the other services there. The other angles I think about this is you can imagine, and I used to work at AWS and Microsoft and whatnot. Like they're really good at providing building blocks, right? Like they're really great at providing the underlying infrastructure, the pieces you need. They're less great historically at building a great end-to-end SaaS product. It's not in the DNA. It's not what they're trying to do. And I think in observability, the same way. If you look at these services like CloudWatch or Azure Monitor and whatnot, I think it's a decent storage for that data. Great, like that's fantastic. Do they have, let's say, these capabilities to show you the efficiency of the data and the cost? They don't really have that. Are those tools really great at like deep root cause analysis and anomaly detection? Like normally the product is not quite as advanced there as what you could find out in the market, and that ends up being a differentiator as well. And I would say that if that's not the case, then we wouldn't have a market. Like if you look at the observability market and who the leaders are, and like if you look at the Gartner Magic Quadrant, who the leaders are, none of the cloud providers there. You see Chronosphere there, you see Splunk, you see Datadog, you see Dynatrace. Like in this market, it feels like it's been tried and tested that products generally will hold against what the cloud providers can provide. Now, if my value proposition at Chronosphere was different, if I only wanted to provide cheap storage of metric and log data, I would actually probably have a lot more higher competition from the cloud providers here because the difference in value is much closer. So I think what ends up happening is as a vendor and as a company that needs to compete with them, I think you need to put a lot more differentiation on the product side as opposed to on the underlying, storage and unit economics. Because if you play that game, you're probably going to lose against the cloud providers.
What's your philosophy on, thinking about what are you going to build next?
We listen to a lot of our customers on this. Like the good thing is you can imagine generally the tech forward leaning companies are containerizing first. They're doing it at scale. So generally we get to work with the companies who are normally at the bleeding edge of their technology stack anyway. And they're the ones that are constantly pushing us to say, cool, you've given me these features. That's great. What is next? And they actually inform a lot of that. So I do think targeting the bleeding edge and the early adopters in a market gives you a lot of input onto product innovation versus if you're trying to build a product that's targeting the laggards or like the vast majority, you're probably not going to be able to get the insights from your customer base there. So I think we're pretty lucky that we target the early adopters and the folks right at the edge, and the innovators, and the tech forward companies, and they actually provide us a lot of um, they provide us a lot of input into how to further improve our products there.
Who are those some of the tech forward customers today? Because it might be different when you first started to, who those customers are today. Like, so talk to me a little bit about those customers today.
Yeah, when we first started, it was, I would say, a lot of large companies that were digital natives. So like DoorDash, Robinhood, like a Firm or Box. Like these are, generally companies that grew up in the 2010s, started off in the public cloud, as opposed to on-premise hardware or anything like that. Generally, they were the first to containerize because they could see all the advantages, and they grew huge businesses in that particular era, and they were really pushing technology there, right? So, that was our sweet spot at the beginning, in like the 2020, 2021 type of time frame. I would say today we actually see, more of the majority of the market now containerizing. So now if you go to like pretty much any big enterprise out there, you pick like a JP Morgan Chase, an American Airlines, like a Visa, like those are companies that are containerizing their environments actually at fairly large scale as well. That they may have been doing it like a year or two behind, those tech forward companies, but the majority of the enterprises are doing that. And it's not just because that's necessarily a definitively better architecture. I think to your point earlier, most companies need to depend on multiple cloud providers today. I see very few big companies taking a single bet on a single cloud provider. In fact, not just do they bet on multiple cloud providers, they generally have a hybrid strategy. They have some portion of their environment that's on premise as well, right? And you can imagine if you have that, you have 2 to 3 different pieces of infrastructure. If you don't containerize what you really, and if you don't have a common infrastructure layer like Kubernetes across that, we can move workloads around. You're really going to have to implement your infrastructure 3 times, and that is, just a very expensive decision. So I do think that most enterprises are on this move to containerization because they have a hybrid and multi-cloud strategy there. And now we're actually seeing a lot more demand from those companies as opposed to just the tech forward companies. Of course, the latest, is all the AI companies out there. The good thing about that is everybody who's starting out at an AI startup these days or a scale up, you're going to be running on modern containerized infrastructure. Like none of those companies are running, like on-prem, even VMs. All of them are containerized from day one, and that's also again like our sweet spot and what we've optimized the product for there.
So is it a big differentiator that you are, focused on containerized applications versus I don't know if Splunk just, looks at that particular just for Kubernetes clusters, or is that a big differentiator in the industry, or
It is a big differentiator, but it's a big differentiator because it solves the 2 pain points when you containerize, right? If we just had a solution that was targeted at containerized environments, but let's say the volume of data did not increase a lot. If that was the case, it wouldn't be a big differentiator because nobody would really care about it. People only care because when they do that, inadvertently, they are, you can imagine when you go containerized, it's not like the containerized architecture gives you more compute or anything like that. It's all the same VMs and compute power at the end of the day. But actually, one of the big differences that people don't think about is your volume of observability data grows a lot, right? So you can imagine when people are doing this, they're noticing that their Splunk bills or their Datadog bills are going through the roof. And that creates a lot of pain on one hand, on the cost side. You can imagine that feeds into one of our advantages there because that's one of the things that we are solving for. And on the other side, again, as you shift more and more workloads there, more often than not, the source of your like problems are those situations I described earlier. So it is a differentiator for us, I would say. And I would also say it's very hard. You can imagine if you take the Chronosphere software and you go take it onto a mainframe environment, it's not going to be it's not going to be very effective at solving those problems. You can do it, but it's not going to be extra effective at solving those types of problems because that's not what it was optimized for. And you don't have a cost problem there. Like it's not like the volume of data has increased on your mainframe. So the there is a little bit of like a product being built for a particular market, a particular use case there that I think it's very hard to have something where like one product is the best fit, is the best solution for a mainframe environment, for a VM-based cloud environment, for a containerized environment. Normally that doesn't happen. You have a different product that's specialized for those things because the pain points and the problems you're trying to solve are quite different between those environments there.
How do you position yourself, or another way to ask this is, how do you market an observability product? And another way to say this is, how do you acquire customers today?
Yeah. So if you think about Chronosphere and what we're targeting, so we're targeting those environments first, right? So you can imagine we will go and ensure we target companies and reach out to companies or try to target companies that are containerizing more than they're not, right? So there are certain, let's say, verticals that are great fits for us, and there are certain verticals that are not great fits for us. So we do scope and target that a little bit. The second thing is if you think about our advantages there of like cost, scale, reliability, you also have to think about which end of the market cares about that, right? So for the same properties, if I go to somebody and you're a relatively small, you're containerized, but it's a small environment, right? If you're a small environment, do you really care about cost efficiency of observability that much? Probably not, because it's not costing you that much. Do you care about 4 or 5 nines of reliability? Probably less so. Do you care about the performance? Probably less so. So like, then you have to think based on our product, or like based on your product, and in Chronosphere's case, all of those properties are really geared towards the top end of the market, right? So all of a sudden now for us, it's like, okay, let's go after large containerized environments there, right? And then beyond that, you can imagine a lot of these properties, there are benefits for the end users, but there are also benefits for the executives, because you can imagine the executive cares about the budget and things like that, right? And observability is also one of those things where I find, especially today in a distributed architecture, it's very hard for one team and one end user to just observe one piece of the stack and get a lot of value out of it. You get the value out of like observing the whole environment and everything interconnected. And because of that, normally you can imagine like a PLG motion where one person would just try to deploy it on their one app doesn't work as well because you can't see a lot of the benefits of the platform. So for us, it's less about that. It's more, can we engage a team who's trying to solve this problem for a whole company? Can we engage an executive who cares about the budget? And we sort of engage at that level and try to look at a pretty large project of like displacing and migrating the whole environment, as opposed to an alternate strategy, which would be, I think, applicable if you had different properties on your business, right? An alternate strategy would be free tier, sign up online, just download it and go, right? So for us, it's not about that. It's more probably what you would describe as an enterprise sales type of motion, where we really want to go sit down with the team, think about it's probably going to be a multi-month effort and an evaluation, but the benefits are going to be there at the end. But yeah,
You mentioned AI a little while ago.
yeah.
How does observability change for AI companies? Or is there a specific trend that's evolving on how do we observe just deploying LLM-based applications?
Yeah, it's a great question. So the first thing we notice is a lot of companies are not like even if you incorporate LLM technologies into your application, you still have application logic as well. You still have CPU-based workloads. So it didn't displace those use cases, which is good for us. But not just that, it added new use cases, right? Like now you have GPUs you are potentially monitoring for inferencing or whatever, and you do need to. It did create new use cases to observe for sure. One thing we noticed is you can imagine at the, like, let's say monitoring a GPU cluster is not too different from monitoring a CPU cluster at the infrastructure level. Yes, there's different metrics, there's different things you're caring about, but like it's still like in our tool, it's just as effective to use our tool to monitor a GPU cluster versus a CPU cluster there. What we also notice is like as you go up the stack into the application tier, and how the at least the LLM part of an application is used. What we have found is actually the base observability types of like a metric, which is again a numerical measure, a distributed trace, which is like a structured set of this happened, like this function call or this step in the process happened, and then this happened and this happened. They're connected, or a structured or unstructured log message. Those types still map very well for debugging what's going on in an LLM like application or use case there. So we actually found that the mapping worked really nicely. And because the mapping of the data type works really nicely, actually all the features and the tools that we build actually work out quite nicely for these apps. So what we have found thus far is we haven't had to change or create a new solution. It's just been more data, more use cases that have been interesting. Because you can imagine our analytics tools are not focused on, oh, this is in particular a CPU based application. What our tools are doing is saying, cool, analyze the distributed trace and look at the steps and compare them all against each other and find out which step is different and because of what property. That translates really nicely to say, actually, on your training runs or perhaps as you're inferencing, like these types of queries are the ones that are anomalous. A lot of those concepts, luckily, I think for us, mapped really well one-to-one. And so we haven't really had to change the product as much for people to get the benefits there. But yeah.
So are your customers LLM model companies who are also monitoring the training of the models using Chronosphere, or
Yeah, we do have customers, so I could be a little bit more careful with NDAs and whatnot. But yes, we do have customers that do the actual training of these particular foundational models as well. So they do also, you can imagine, have huge GPU clusters that they're using for that training. Yeah.
and that process has been, from what I've learned, it's not as stable as when you're running
Yeah. Yeah.
a CPU, general
Yeah,
workload.
it is definitely not as stable, and especially in the training component, there are particular steps where if one GPU fails, like it holds up the work of all of the other, I don't know about all the other, but a lot of the other GPUs. So like that one GPU failing could be, and you can imagine training these things cost billions of dollars. Like that single GPU failing for like a minute could cost you a lot of dollars in this particular thing. So there is a huge advantage even in the training phases to have low latency and great observability so that when you detect something like that happens, you can switch that out really quickly and not take the additional cost. So there are definitely huge advantages. Again, the good thing for us is, you can imagine that's a metrics-based alert for example, to detect something like that. So we can handle that use case. But yeah, they're definitely different. The benefit is potentially even more so on at least at the training stage of these GPU based workloads. But yeah.
So it looks like your addressable market sort of suddenly increased with AI training, compute, and technically, right? So, how are you thinking about leveraging AI for your own product? Like,
Yeah.
are there any use cases that you're already tried that's working? What's working for you? And
Yeah.
talk to me a little bit about that.
We have been trying and playing around with it a lot. I would say what we found um, initially, and it's not just for us, like every product out there, I think initially just, put an LLM, train it on their docs, and you have this like chatbot help thing. Sure, great. Like
Yeah,
everybody has done that.
that's the first thing
Yeah,
everyone does.
exactly. Sure. Like check the box there, that's done. So I think what we have found is really, and what's interesting, and we're spending a lot of time here right now is what's interesting is a lot of the data that we have is, you can imagine, a lot of that data is numerical. So that's interesting. A lot of the data is generally unstructured. Even if it is structured, it's not like, the way you name a variable, that's something you would put in your observability instrumentation is not how you would write a paragraph or an email, something like that, right? So it's structured. Even the bits that are English and like are not quite I think what these models are used to. So what we have found is when we try to apply take a foundational model and try to have it look through the raw data, it's actually not very effective. And you can also imagine that's also because, it's not trained on a lot of observability data. A lot of observability data, by the way, is unique to a company because it has a name of a service, it has a name of a host. Those are things that are
Right.
unique per company versus, like the law is the law, a human body part is a human body part. That's generally, A, people are not feeding private observability company into these models for training, and then B, they're pretty different from company to company there. But what we have found to be effective is already like put LLMs and AI aside a second. When we have had to build our products, we have this problem too. Like there's no normalization on the underlying observability data, and like just providing that to people is not very useful. That's almost like again, I'll hit on AWS here, like CloudWatch. It just the access of the raw data just doesn't help you with anything. So what we've been doing for a couple of years already in the product outside of AI has already been to extrapolate insights and structure the data in a way that's more like a knowledge graph, and normalizing a lot of that textual data. So we've been doing that anyway because those knowledge graphs actually power our analytics engine. You can imagine if something goes wrong, we need to know who all your dependencies are. We need to do the correlation between those. We've had to do that anyway for our product. What's interesting is when you feed those knowledge graphs and the real structure that we've done, scrubbing the data into the models, then it gets a lot more effective. So that's definitely one area we're definitely deeply looking into right now. I think we lucked out that you can imagine data scrubbing and normalization is not an easy process, right? It's like we built a lot of tools. It's like it's underscore here, but it's dot separated here. If you reference like DC here, really means AZ over here. Like a lot of that. And I think there are companies out there doing this for AI data right now, right? But a lot of that is actually the hard work to make the data valuable. And luckily, we were doing that already for our product and our UI features. Now, when you feed it to these models, they do become more beneficial that way. And the last thing I'll say about this is generally in observability, I still don't know if the chat, at least initially, the chat interface is the right one. I can't really imagine you get paged, right? You get onto a thing and you just have a chat interface and you're like, tell me what's wrong with this. It just feels like somewhat unnatural versus, our interface right now is like, we know what's wrong. Let us visually show you graphs and
Yeah.
things like that, right? It just feels like, at least as a starting point, a more natural interface for the observability use case. Perhaps as you explore and ask questions and whatnot, there's maybe a bit of interaction there. But honestly, like a lot of our analytics tooling, like you don't need to we know what your question is going to be. Your question is going to be, oh, there's a correlation here. Well, is there a deployment here, or is there a feature flag? Like we know what those questions are going to be, so we just go and run that analytics for you ahead of time and sort of just give you that answer. So anyway, it's my long-winded way to say there's definitely, I think, potential when we're looking at it, but there hasn't been like overnight magically all you need is an observability agent and that's it. You don't need dashboards or anything. You need it can answer all your questions. Like we haven't found that to be the truth, and I don't know if that's where the industry is going right now. But yeah.
I mean, when you're speaking about observability data, the thing about that data is it's almost like complete opposite of um, your code data. For example, like the reason why like Cursor or Claude does so well on code is because of the logical structure is very defined,
There's logical
right? It
structure.
follows a pattern of the language and the,
Yeah. There's human comments. There are design patterns. Observability.
yeah.
There's very little of that.
It's
It's
the
like
complete opposite. It has
yeah,
nothing, right?
yeah, yeah.
There's no explanation unless like the SRE comes on the call and looks at it and tells you what it is.
And again, I think a lot more code, or at least patterns in code, are probably going to be a lot similar between companies. And so when you're training, and a lot of this code are in open source GitHub
Yeah.
repos and things like that, observability data is very, very unique per company as well. So what may be greatly trained and optimized for one use, like for one company, may not work at all for another company there. So there's just odd things about, I think, observability data that you can't just do the standard out of the box way. And I think that is why right now there isn't a huge, there are a lot of code generation tools out there. There's not a lot of huge effective, observability agents out there, right? I think there's a few startups in that area, but to be proven that is going to really fundamentally uproot the market here. But yeah.
Do you think like there's an opportunity for like creating adjacent products here? Like, I don't know if Chronosphere integrates into like incident response systems, but if you have observability data and incident response data, like you could probably create almost like I don't know if it's a RAG sort of a product or that helps customer support and SREs. Like, is that something that you guys think about?
100%. And I think when we think about that, so already, again, putting AI aside, we already have integrations with incident management products like Rootly and Incident IO and things like that. So the product's already integrated, for example. Now, when you add AI into it, I think the real question is, you know, is there a world where there are fewer agents that can access more data through like MCP or something like that, right? Like you have one agent that can, not only interact with your incident data and your observability data, but maybe your deployment system, your CI/CD system, your feature flags system. You can imagine putting all of those in one place, like could be interesting there. Or perhaps every vendor does end up creating their own agent, and Google just came out with the agent-to-agent protocol. Like, do the agents just talk to each other that way? I don't really know how that's going to unfold, but we're definitely sort of heavily looking at both. We were a launch partner with Google for the agent-to-agent model there, and also we're exploring, like, is MCP the way the world unfolds? I think things are developing very quickly, obviously, on those fronts there. But I do, in my mind, I think there is value, like in an AI world, there is value in the underlying observability data. There's a lot more value if that data is structured in some way that's not just raw access there, right? And then I think the value is, to your point, part of a bigger workflow. You just, like, the workflow end-to-end is not just observability. That's going to tell you what's wrong, and then you're going to have to do something about it, right? So, I do think there's value there. The question is, like, how does that unfold? And like, either you have to be a vendor that owns all of those pieces of software, which I don't think really exists if you look at the market there. So if you have individual vendors along that chain, how would that end-to-end workflow come out? And I think that's either going to be, today, if you look at the world, it's either going to be agent to agent, or MCP is probably the way that's going to go. So we definitely spend a lot of time thinking about that, trying to get ahead of it more than anything else. But yeah.
One last question around the AI topic is, you're not just thinking about the product, but also the company, right? As a CEO,
Yeah.
and you have different factors to think about: profitability, unit economics, and all those things. How much capital expenditure.
Yeah.
Like, does AI improve the profit margins for you? Or are there ways, like, you're thinking about, um, get to profitability faster because you have certain tools that you didn't have before? Like, is that a real thing that is happening, or is it just currently, more of a narrative than reality?
I think that is in my gut. Is it are we moving in that direction? I think yes. I think I don't think about it like, I think there are folks out there that are like, oh, if we are 30% more efficient in our developers, could we just cut 30% of them? I don't quite think about it that way. I think more like, cool, if we're 30% more efficient, does that mean we don't need a high, like, our hiring rates can be reduced because we can do more with the same amount of folks we have today? So I think in terms of like cost cutting near term, probably no, that's not the way I'm thinking about it. Plus, also, I just don't think these tools are that mature yet. We're not talking about like replacing folks, and also it's not a great company culture to set there. Like, imagine if your CEO said, "Hey, we are so much more efficient. I'm just going to cut headcount." That's probably not a good sign for that company. Or it's probably not a good sign for the employees of that company, right? That they think like that. So, I do think there is starting to be concrete efficiency gains under these tools, just not only on the engineering side, but like on a go-to-market side. These tools are hugely, like, I use these tools every day to save me time. I do think there's efficiency gains. I think it's quite hard to measure what those are exactly. Like, I don't think there's a line item that's like, my AI efficiency gain is like 20% or something like that. I do think it ends up translating into, as you get more efficient there, as you think about what is the additional investment needed for something, you probably think, like, change the way that thinking happens. So I think we'll slowly see it, in the financials of a company that way. At least that's the way I'm thinking about it, as opposed to really hard 20-30%. That means I can save, like, X millions of dollars and cut X headcount. Like, I don't think the science or the tools are quite there yet. But yeah.
So we're almost at the end of our conversation. I ask a couple of questions at the end to all my guests. So the first question is, what do you know about starting a company that you wish you know earlier?
um, that I'd assume early in your career, if you want to be the CEO in particular of a company, you probably need to go get an MBA and have all this experience as an executive. I'd say I found that not to be true. I don't have an MBA. I don't have experience as a big executive at a company somewhere. So that's probably one thing I'd say is, like, a lot of founders I know, I don't know if they're very different from everybody there, right? I was a engineering manager at Uber before I did this, right? Like I think there's more. Um, I don't know how to say it, but there's probably less of a barrier for somebody to become a founder and a CEO than perhaps one may think, looking from the outside. So it's probably one thing I'd have thought about differently from like 10 years ago. But yeah.
What are you consuming right now that's influencing your thinking? It can be anything, books, audio, video.
A lot of conference talks actually. A lot of conference talks on you know, a lot of the topics that we just talked about. I think like, especially anything AI related things are evolving so fast. I don't know if there are books written by any of this stuff. Like by the time a book comes out, like it may be maybe outdated already. So I think, like a lot of conference talks and talks and things like that. Even with the AI tools, you can like summarize a book. Like I'm not good at like spending, 8 hours on a weekend reading a book, like, but I know there are books out there that there are some great lessons to be learned there. So like trying to consume it that way. Podcasts for sure, because again, like I think I think the trend is there are different mediums of getting information out there at the bleeding edge, and I think things like podcasts and conference talks are probably better access to what's happening live, versus historically like a research paper even takes a while to release. Like a book takes like even longer there. But yeah.
Martin, thanks for coming on the show, and looking forward to what Chronosphere does in the future.
Thank you. Thanks for having me. Enjoyed the conversation, and hopefully we can do this again at some point.